In this next example, we have an open loop function T of S and the Nyquist plot obtained for that open loop function. The objective is to evaluate the stability of a closed loop system if T of S is used as the line function. Assuming, of course, that this feedback loop is a unit negative feedback loop. Given the Nyquist plot, we now need to count the number of encirclements of -1 and count the number of unstable poles that the open loop transfer function has. This function has two poles, but only one pole is unstable. That is the pole at +9. The pole at -5 is stable, so P equals to 1. The open loop transfer function has one unstable pole. Now looking at the Nyquist plot, we see the number of encirclements of -1. And this is +1. The Nyquist plot encircles -1 one time in the clockwise direction, hence the positive sign. The number of unstable poles now of the closed loop transfer function is simply P plus N. This is 2. So the closed loop system, if put in a unit feedback loop again, it would be in this form, would have two unstable poles, and this closed loop system is unstable.